Good afternoon, everyone. Welcome to the Autonomous Vehicle and Self-Driving Cars Research Platform webinar, jointly organized by SABS RDS and QLab Incorporation. My name is Ralph Saab, and I am the co-founder of SABS RDS, with more than 20 years of experience in the research and education consultancy in the MENA and Gulf territory. SABS RDS is yet a 2-year-old company. We are gathering a background cumulative experience of over 50 years of engineering consultancy and long-term partnership history with the research and innovation market specialist and expert. We pride ourselves in a value-added proposition into your application challenges while reinvesting in the local market via supporting the students' projects. We help enabling the bridging of the local industry granted challenges into the domain experts in line with Vision 2030 and the localization of the know-how and domiciliation of the knowledge. Our team services multiple segments in the education, the research acceleration, Industry 4.0, prognostics, aerospace and defense, 5G, power, technology transfer, business coaching of SMEs and startups. And for sure, we are widely covered for topics of the day, the autonomous vehicle and the drones platform. We partner with well-reputable world top leaders in the research industry and business consulting, such as kwonzer, National Instruments or NI, PTC, CB Technologies, Allied Reliability, Bitless-Man, and others. We have already established several success stories at several giants of the local market, and we are eager to continue being part of their successful projects. SABS RDS is in perfect harmony with the NIDLib guidelines to enable the success of the Vision 2030 in the Kingdom, with main focus on its 4 pillars: the industry, the mining, the energy, and the logistics. The success of this initiative doesn't occur without focusing on the biggest capital here, the human asset, via continuous training program and technology transfer. SABS RDS is looking forward to collaborate with you to be all as part of the vision in our region development. We always strive to learn more about your challenges. That's why during this seminar, please feel free to type your questions or comment on the chat box in order to be able to address them at the end. Also, I would like to remind you that this webinar is recorded, so please mute your mics so that the presentation will run smoothly. I would like now to start introducing our first speaker from kwonzer, my colleague Tuvishan. Mr. Tuvishan Rajalusingham, who is the Global Digital Product Specialist at kwonzer Incorporation, a leader in the real-time control and mechatronics solution for education research, where Tuvishan develops regional partnership with universities and distributors from across the globe. We have also from kwonzer, Mr. Isa Al-Badawi, the Channel Partner Manager at kwonzer, responsible for developing regional partnership with universities and partners in the APAC and the GCC region from kwonzer. In addition to our both pioneer presenter from kwonzer, Tuvishan and Isa, we have as well the application engineering and support team leaders from kwonzer, Mr. Hernando and Mr. Murtaza, who will be joining us to answer all your technical needs and technical questions whenever is needed. Mr. Murtaza Bora is the R&D engineer with the academic application team the academic lead of the Q arm and used to be the application lead for the self-driving car research studio. Murtada, he holds as well a master's degrees from the University of Toronto in robotics and space mechatronics. And at kwonzer, he specializes in the software architecture of autonomous and unmanned vehicle. Mr. Hernando Pineros is the mechanical engineer with extensive experience in the control system, mechatronics, and robotics. He had worked with kwonzer for over 12 years. Hernando works closely with end users and business partners worldwide, providing them assistance, training, and support. So guys, everybody, please welcome Mr. Tuvishan. Tuvishan, the floor is yours.
Thank you very much, Ralph. Let me jump through. So thank you very much for the kind introduction. With regards to kwonzer, many of you may know who we are, some may not. I'd like to take a quick second to give you a brief overview in addition to what Ralph had mentioned. But in terms of the topic of the day, we are discussing platforms for autonomous vehicles and self-driving research cars, along with additional means to modernize the way engineering teaching and research is currently being conducted globally. So for those of you who don't know, kwonzer is actually a combination of question plus answer, and that's where we get our roots. We are an academic company, and we strive to empower professors and researchers with the joint goal of taking on some of those challenging tasks of embarking on innovative solutions. So with regards to who we are, again, we're an academic company for over 30 years, been in academia. We have over 80 solutions in a variety of different verticals for controls, robotics, and mechatronics. And with that, we've been able to amass over 3,000 research papers, that have been published on our works. But this is the topic of discussion is very relevant for today. And the reason for this is we're faced with a global pandemic. And with the institutional ties that we have and the partnerships that we've built over the years, many institutions look to us for support, especially when times are changing. A good example is Dr. Jinjun Shan from York University out here in Canada, our backyard, where he came to us and he was asking us, how do we support our students in a modern way where the perceived quality of education is not lost through online means? So that brings us to a very interesting question, which is kwonzer has now started to embark solely on supporting a holistic view of engineering education from both the teaching and research side on a more complete picture. And what I mean by that is, for those of you who have ever worked with us, we develop quality, open architecture, robust hardware that's turnkey and allows you to develop in platforms and environments that you're comfortable with, such as MATLAB Simulink, LabVIEW, C++, in certain cases Python and ROS. So we've always been the leaders in real-time control, and we've always had quality, robust hardware. Now what we've done is completed that solution by offering virtualized solutions and online methodologies to teach or to explore research in a rapidly developed way. And I'll show you exactly what we mean by that shortly. So before we jump into the nitty-gritty, we wanted to really express our excitement about this newly launched solution, which is our virtual solutions around the ground robot, the mobile ground robot, the QBot 2E, our Cube Servo 2, kwonzer Aero, and the Q arm. So these four virtualized solutions effectively allow you to put a piece of hardware, now virtualized, on the computer of every researcher, student, or professor, so that you are able to rapidly test your algorithms in an environment that's comfortable for you, such as MATLAB Simulink, and deploy it on the real-time hardware so it's a parallel experience. Meaning you're no longer limited by just your lab infrastructure space. You're no longer limited by the lab time that you have. You're able to take this home and develop on your own time. And for the students, the amount of power that puts into their hands is there's limited IT infrastructure support required. and they can effectively enhance their learning experience. And this is the future that we envision, where you have solutions that are being developed in real time, tested in real time. You come to the lab and you deploy them on the actual physical hardware, correlating the results. So what you should be seeing on your screen right now is a pick and place mechanism. So this is our kwonzer arm, the Q arm. This is a 4 to 5 degree of freedom robotic manipulator. The goal is to identify the object, and the control algorithm is using or manipulating the dynamics and kinematics of that robotic manipulator to locate the object, grip it, and then deposit it in the correct location and then repeat. So my background's in mechatronics engineering. When I was working and studying through school, effectively, we were always limited by lab time and availability of the hardware. You would get maybe an hour, maximum an hour and a half to get to work on these equipment. And half the time you're trying to rapidly test to see if your algorithms or controllers were working. This puts the power back into every individual's hands, where they could be deploying and testing at home and validate their thesis or assumptions even on a research setting. So let's delve deeper into exactly how that might work. For our research applications, and we're going to be touching in terms of some of the studios that we have developed for aerial as well as ground autonomy, such as the drones and self-driving cars. We took this as an example, and our director of engineering developed what he calls a simple algorithm, a lane keeping algorithm, and this is based on a 1/10 scale model of a car. So using MATLAB Simulink and our designed software toolbox that enables you to rapidly prototype, called Quark, he was able to develop rapidly a algorithm to have a self-driving car follow a line and conduct its steering so that it would maintain in the center of the line. And you'll see exactly how he was able to test this in his basement in real time. So as we pull up the videos, you should be seeing a 1/10 model of a car running around in a circle using a high fidelity approach to testing his controllers. And the best part about this is, and when you start to empower the solution using visualization, he was able to take this exact model and replicate it on our ground robot, the Qbot 2E, to develop his algorithm and fine-tune it before implementation. And you'll see an example of this here, where when you put the power back into a researcher's hand, you can really quickly develop algorithms and controllers in a short period of time. And sorry, I'm just trying to get these videos going for you. There you go. So you can see how he was able to take that exact same lane keeping algorithm, deploy it in the virtual environment on the Qbot 2E, and he was able to identify parameters to optimize before testing in real hardware. So the power behind this is when you have limited ability, or you are trying to optimize your procurement for your institution, this is another means to be able to scale your ability to approach a more modern way or a holistic way of both teaching and research. But now this is on the virtualization aspect, and this is really good for empowering both students and researchers that are looking to explore on kwonzer solutions, both in the virtual environment and the real world. But when we jump into the real world, we understand that there are differences. So I'm going to pass it to my colleague, Isa, who will be able to outline exactly how kwonzer has worked with institutions globally to develop these exact applications, but now beyond that, empowered professors and researchers to take that one step further on the actual physical hardware.
Thank you very much to Vishan, and thank you, Ralph, for the presentation today. Assalamu alaikum, everyone. My name is Isa Al-Badawi, and I will be giving you guys a brief introduction to our unmanned systems. Firstly, I would like to thank you all for joining us today. I'm very actually excited to share with you more information about our systems. So what I'm going to do here, I'm going to start with showing you an introductory demo video of how the drones and the systems look like. Then after that, we will dive into a deeper discussion. Oh, thank you all for watching the video. So as you can see here, one of the core elements of our ADRS offering is the Q drone. So looking back 20 years ago, we have developed our first stationary kit for flight dynamics. And with the technology enablement these days, and also with the receiving feedback from partners like yourself from universities all over the world, we have released in 2018 our second drone, a research platform that is meant for research group who are looking to jumpstart that research application in a very short amount of time. So as important as the drone itself, in what we are offering, it is just a small piece, to be honest, in the full sort of a package. So we have developed a package, a full studio, as you can see here from in the pictures, as a testing bed to facilitate publishing, as well as facilitate research for professors and researchers all over the world. So this turnkey solution, as you can see here, requires only a space from yourself, and we'll be able to provide all the infrastructure required to run the hardware, all of it by itself. So we have spent a lot of time and effort in the infrastructure, as you can see. So the system will have localizations cameras from the top picture, and also we have the product itself, which is the drone, and some ground robot. It's a QBot 2E, and also will be offered with the Wi-Fi configurations. And the big development part is the high performance PC that comes with 3 monitors, which is called the control stations. So it will come pre-configured with all the softwares needed and all the tools and libraries required for the full sort of like running of the system itself. And we also took in consideration some safety measures. So the system will come with some safety nettings, and also will come with the mattings. So looking back at the drone itself, so the main aspect that we could highlight here for the drone is that it's a system that is open architectures, which gives you access all the way down to the IMU, and also give you access to send signals directly to the motors. So with this sort of ability, it gives the user the ability to tune and rewrite the controllers as they please. And this allows different topics of research. These are some of the examples that you can actually target using our autonomous vehicle research studio: some advanced flight controls, swarm intelligence, machine vision, SLAM and autonomy, and so forth. And just give you an example of one of our colleagues in Poland. So back in 2019, January, they bought from us a studio of 6 drones, and within 3 months, they were able to publish their first research paper that was published on ResearchGate itself. So I'm going to start here with a video that shows an example of one of our partners here in the US that utilized the studio to expand their research applications in dynamic trajectory. So as even you can see from the video, some of our legacy products, which is the QLab 2E at the back there, it was part of their research application before. As soon as we have developed the Q drone, they adopted it for their more advanced research applications. So the drone itself is just a flying computer. It is powered with an Intel board that have a barometers and IMU in it, magnetometer, and also give you direct access to the IMU and GPU itself. They have Wi-Fi capabilities. And while designing our drone, we took in consideration the expandability configurations. So the system will come with expandable IOs that offer the user to mount additional sensors, additional components to target different research applications. And also the drone itself comes with 2 cameras. One camera is facing on the x-axis, and the other camera is facing on the y-axis itself. So moving forward directly to our ground station. So the AVRS also consists of a ground robot, which have a Raspberry Pi into it with the integrated Wi-Fi internet, a video processor, and an RGBD camera. And also it offers expandable IOs for researchers and professors who are looking to mount additional sensors, additional components to the hardware itself, just to target different sorts of research applications that they might be looking at. So in terms of the software part that we'll be talking about here, so the system is powered with one of our software, Quark. So Quark is essentially as an add-on to Simulink. So it's seamless, you will not even know that it's there, and it allows the researcher and the professor to have that real-time communication with the hardware and the system itself. And it with that open architecture that we offer from our solutions themselves and with the software itself, so you have the ability to tune controllers, change controllers, and see them like change directly on the fly on the hardware itself. So now moving to 2020, we have relaunched or released our latest offering, the self-driving research driving car. So a system that is available for researchers that want to accelerate their research applications, whether you want to implement your ideas on a new solutions or to catch up and compete with other groups in the same fields from all over the world. And these systems have been implemented with hundreds of users all over the world. So the system is fully open to groups that are already doing work. So if you're already doing work, I will talk more after this about the software side into it. So we want, you can apply your knowledge on these systems, whether you're using Python, whether you're using ROS, whether you're using MATLAB Simulink. And just to put in mind as well, kwonzer have been in the industry for over 30 years. So we will always support you if you decide to collaborate with us. And our software have never changed for 30 years. We've been developing it, and always we are always sending updates to our partners and universities all over the world. And we have a full team of engineering that is ready to support you whenever you have some questions. So this comes back to the Sustainable Driving Research Studio. So kwonzer will be there for you if you have questions like next year, 5 years from now, and 10 years from now. Our systems never changes. So, so here is some feature summary of the hardware itself. So as you can see, the car, it's 1/10 scale of an actual car. It have 4 CSI cameras that offer 360 degrees view, an RGBD camera mounted at the front. Also, you have a 2 degree of freedom LiDAR, and you have sort of like signals horn in itself. And you also have sort of like expandable IOs in case you're looking to add additional sensors into it to expand your research applications. So as you can see here from the pictures, we have taken consideration an impact-resistant design. So you can see the car is running into a wall, and since the car is 1/10 scale of an actual car, this is similar to an actual car that is running into a wall at 120 kilometers per hour. So the system is robust and is ready for research and is research-proof. So not only that, we're making sure that research group from different backgrounds can use the hardware, but we are trying to allow different groups with different software background to interface with the same hardware. That's why we're implementing in our sort of a platform that the system can be programmed and you can run your algorithms either using ROS, Python, MATLAB Simulink using Quark. So as an example that I can bring on this one, Khalifa University in the UAE, they have collaborated with us last year, and they bought like a 10 drone and ground robot studio. So they have 2 independent groups. One of them is writing the algorithms on Python, and the other one is writing the algorithms on MATLAB Simulink. Those 2 groups are completely independent, and they're using the same hardware. So we are trying to bring different sort of like background programming and interfacing softwares into the same hardware, just to allow those research groups to communicate with each other and come up with some optimum sort of algorithms. So as you can see here from the picture, from the slide that I have here, these are some Python and Simulink examples that will come as a library to facilitate your interfacing with the components of the car. This will give you time to focus on developing your algorithms, and you will not spend a lot of time interfacing with different parts from the car itself. As we can know, if we're buying a new product, or if we are developing a new product ourselves, yourself as a professors and researchers, there is a lot of time that you spend on trying to interface with the component. So we have brought that to you all as a package. All what you can do, open the box, we get that all set for you on your lab, and you can start writing your algorithms and test your ideas. So here I wanted to highlight as an example that we've done using Hector Slam algorithm in ROS. So what we have used, we took the car and we only used the LiDAR to map up our office here in Canada. So we did not allow the interfacing of the cameras, as you can see it. And as you can see, it is comparable 100% to the picture that we took from Google Map itself. So looking back at that expandability capabilities that I was talking about, so we are leveraging the Unreal Engine, and which allows you to implement your ideas in different environments. So what we have done as a company that is looking always to thrive and to be the pioneer in all of these, the new innovative ideas, we have brought different environments to your testing lab. And so you can test your algorithms. Either you want to test your algorithms on snow or on sand, on desert or on wet ground that you see there. All those different environments and conditions have been brought directly to you to your lab, so you can implement your ideas on these conditions, and you can compare them with different research groups from all over the world. So we are trying to build a community between researchers from different parts of the world to work on the same testing bed, and they can refine their algorithms for a real purpose, for industrial purposes. So now looking at this video, as you see here, we have implemented a slightly different twist into it. So as you can see, the car is moving in an empty room from the top video that you can see from the left-hand corner. And we're taking the front camera and we are feeding and injecting into a virtual environment. So essentially, the car is moving in an empty room, but the computer that is running on the car itself, which is the NVIDIA Jetson, is thinking that the car is running in virtual environment. So with this sort of capabilities, this allows you to do real-time augmented reality research applications that are trending right now, and you can build your own environment and you will be able to test your ideas on it. So in summary, this is how the system will look like. So when we're talking about the self-driving research car, so we brought the full package that comes with the high-performance computer that have all these softwares already pre-configured in it. It have the 3 monitors, so the computer by itself. It also have the hardware itself, which is the car, and it also have different roadmaps. So looking back at the different roadmap that we have, as you can see here a video, this is 1/10 scale of an actual sort of a road. So from the bottom picture, you can see different types of roadmaps that will become as a package of with the SDRS solutions, and we're also trying to add into it some signs that you can implement in your research application in case you're using multi-agent sort of solution, or sort of like research applications. So with this, I sum up my part of presenting, and I thank you a lot for listening to us today. And please, if you have any questions at the moment, please feel free to share them with us on the comment section. I will be more than happy to answer them.
Thank you. Thank you so much, Isa and Tuvishan, for this excellent presentation and this very exciting technology that you are showing us today for the first time. Thank you as well, all the participants and all the attendees, for your time and your interest in our webinar. And I'll give for you as well one more chance. If you have any questions, please feel free to ask or to address it directly to our speakers, so we can immediately solve it.
Hi, everyone. I have a question. Can you hear me?
Yes, we are listening.
Hi, how are you? Thank you very much for the interesting presentation, and thank you for introducing QANSR applications. I know that today's session is concentrating on the research platform, but I have a question regarding the educational platform. I've used QLab, like experiments as a supporting material in one of my courses in the past summer, but I had a problem with the disconnectivity between like the students and between me, the instructor. Are you planning to make like any sort of virtual rooms or virtual classrooms where I can see the progress of each individual students using the platform?
So
Yeah, I guess this question Tuvishan can handle it.
thank you, Ralph. So firstly, great question. Again, reintroducing, my name is Tuvishan. I'm looking after the global digital solutions, QLab included. So with regards to the feedback we're getting globally, And to maybe address your specific situation, the initial solution that we had originally released was a trial-based version. So for the new individuals that are coming onto our platform, it's a subscription-based model. And what would happen is when they purchase that subscription, there's actually an academic portal that we've developed. So on that portal, as a instructor or session manager, you're able to get insights and glean analytics based on how your users are interacting with our platforms on QLabs. However, to maybe address it specifically, we don't have any virtual rooms per se where you can all call in and be working at the same time on a video platform. However, there are other resources available such as Zoom, Teams, and so on that allow for that. Effectively, what we wanted to develop was a lab-like experience that could all be locally sourced on each individual PC. And the way instructors have been using them globally is you'll have a lecturer or a lab manager present their screen. They'll be working either on the real hardware or the virtualized hardware, and students would be following along in real time.
Thank you very much. For the virtual classroom, I don't mean you know, like classrooms or like platform, just like Zoom and Teams. I mean, just like the one that, for example, like Tinkercad developed, that you can actually access the students' platform and see their progress in real time, like while they're working.
Gotcha. So with regards to our academic portal, there's no insight to be able to access them as they are working. Effectively, what it does is it gives you analytics based on their engagement with the actual solution. But for example, on each individual case-by-case basis, if there's a specific application that you need, perhaps we can take that offline, and I'd love to discuss with you, because what we're doing is as we're building these platforms out, we're understanding what the market feedback requires. So because it's all in real time, if that's a specific need for you and maybe there is a unique reason for it, I'd love to delve deeper and maybe understand how we can work with you collaboratively.
Thank you. Thank you very much for answering. You mentioned the subscription. If there is a way that you can get back to all the attendees with an email about the subscriptions, that one that includes the educational platform?
Absolutely. So I'll work with our team at Sub to follow up for sure, along with additional material regarding what's included in that subscription. We do have a promotional video that is coming out, so we can attach it in that email, and we'll be able to get you those that information.
Great. Thank you very much.
No problem.
Thank you for your question. Very interesting one. Any more questions? Yeah, we have one question here. You spoke of swarm intelligence and collaborative driving. How do the QCars communicate? Do you have onboard electronics to scale the V2X chips / technology that we have available out there now? This is a question about the QCars. Maybe Isa, can you address this?
Murtaza might actually have more information on it. Murtaza, can you actually assist with this?
Sure, I can take that question. So the QCars as a technology is developed to help you enable research and improve your research performance and experience. And so what we are trying to do is replicate the environment that is out there in the real world in your research lab so that you can test your algorithms. So in this case, we haven't directly implemented V2X chip or technology on the QCar itself because they're a 1/10 scale platform. However, the QCars and the research studio comes with a communication infrastructure in the form of wireless technology, and all the cars automatically connect to that network. So from the car's perspective, all your cars are automatically connected. And so they can exchange information using your standard protocols. And when you're ready to test your algorithms onto real cars, the only component that would change is instead of using Wi-Fi, you would switch over to V2X.
Does
that answer your question?
Yeah, does this answer the question? This is what I'm trying to say.
Thank you.
Excellent. We have another question here. I'm a master's student in energy engineering, and I want to test several algorithms for load predictions. How can I use this platform? Can you handle this as well, Murtada?
Sure. I'm trying to get a little more context on this. Which platform is this in regards to?
I guess this is the QCar because this is within the same topic. If I
Testing
got the question.
or load prediction.
Yes, the QCar.
Okay, QCar. So I'm going to make a lot of assumptions here. Load prediction in terms of the load on the vehicle's transmission and wheel system based on the road conditions, or are you talking about the effects of having a load behind the car being towed with the car? If you can give me a little more detail, I should be able to answer it. But there are ways to monitor the electrical power consumption on the car directly. We have both the electronics current sense as well as the current sense in the main driving motor, in addition to being able to monitor your battery voltage. So you can take a look at how your power electronics for the car are changing depending on the acceleration, the torque commands, and the steering commands you're writing to it. And that can give you some sense of the load on the vehicle. Now, given that it's a 1/10 scale model, a lot of the dynamics of a full car don't directly apply to such scale models. But in terms of the algorithms and research in self-driving, the platform should be able to hold up pretty well. Does that answer your question?
Let's see. We are waiting for the answer. I guess the assumption direction that you took, it should be the one that it was intended by the question, unless we misunderstood it. Could you please tell us if this answers your question, or if there are any other question to answer? It seems that we no longer have any question.
Yeah, we can proceed for now.
Yeah.
If he comes back, we can answer that one.
For sure, for sure.
Thank you.
So, yeah, thank you, but I want to know how to fetch this software. I don't know, what do you mean by fetching about the software?
In terms of the software interface to the vehicle, all of that happens through MATLAB Simulink via Quark, as well as Python. So when you acquire the self-driving car studio, it will come with a complete ground station. This will include all the software necessary that you need to use to be able to interface to the car. It includes the communication infrastructure and so forth. So it's really an out-of-the-box solution. And it'll have a lot of different examples, tool chains, and APIs for you to be able to connect to the device via directly MATLAB or Python. And you can also directly work on the car itself. So you can use the QCars as a computer in case you want to do direct learning on them.
As an embedded computer, you mean, I guess. Correct, perfect. So this was as well very well understood by the person who asked the question. So this is via MATLAB and Python. Any more questions? Okay, you are welcome, everyone, and I guess by this and I guess by this last question we are closing the Q&A session. We hope and wish that we could cover the majority of your question, and in case you have any more comments or thoughts, please, questions, feel free to interact with our team, with our support team, with our team at SABS RDS, and we'll be more than happy to support you with the latest technologies from our top partner, kwonzer, and others as well. Our event reached its end. Thank you all for your great questions, feedback, and most important, thank you for your time. We are very honored to have you in our event, and please reach out for any further question. We would be more than happy to hear your problems and provide you with the right solution. Have a great day and thank you. Yes, yes, indeed. We will be interacting with all the audience by giving them a feedback. Thank you email for attending, and it will have all our contacts. Thank you.